Now we are cooking a hard candy, a little one. And there's a solution side. We can see how far it is down and how it is getting in the state. Like and finish. Now, what the final one, sure that it gets really solid and the hard candy we cook up to 130, 135 Celsius degree to get actually texture in a very minimum level. Soft candy, there's cooking currently, and soft candy, we are cooking a little less temperature since our moisture content is a little bit high and a little bit high than hard candy, and the ingredients quite different. In soft candy, we have mainly based on starch-based ingredients, of course, sugar and glucose syrup. Sugar and glucose syrup is the must of the candy, must of the confection. Of course, this is the most enjoyable part. And the other part, after we cooked, we will add acid, flavor compound, and the color of it. Sometimes what do you have in this? Actually, this includes glucose syrup and just glucose. What type of glucose syrup we have? Actually, this glucose syrup, which we generally use in a hard candies, 42 dextrose equivalent glucose syrup. Which means we have mostly maltose. Yes, maltose, mainly 42 glucose, and the rest of a little amount of bulk carbohydrates, but very little. Okay, of course, during the heating, during the heating, that's kind of bulk carbohydrates do not affect the texture. Okay, since we cook up to 130%.
We would add the acid after cooking.
Yes, after cooking. Also, the cooking time is very important. In industry, generally, one batch of cooking hard candy takes much more less time than we do, since we use generally steam. Some industry use oil bath to get high temperature in a very short time. Now we are using that electricity to get heat, but eventually we will get the final product of the hard.
How do you know that it's done? What are you looking for to know?
Now we are
far enough.
Yeah.
You check the temperature,
Yeah.
the final
The
temperature.
final temperature. When we reach the final temperature, we desire the cut off the actual cooking procedure. After that, we will mix with the citric acids. Flavor and the color mixing, and the whole candy mass will be cooled a little bit. After it's cooled down up to 80, 90 Celsius degree, we will cool it into the mix.
Why do you add citric acid?
Actually, citric acid purpose. Enhance the flavors. For our flavors today, we are mainly using actually fruit type flavors. Okay. So fruit type flavors, citric acid, malic acid, tartaric acid, can kind of acidic agents can be used to enhance flavor into the candy. On the other hand, there are kind of milky products which we will not proceed today. That kind of milky products, flavor can be enhanced by milk powder, butter, cream, that kind of stuff. But for fruits, acid is a very good agent to enhance the flavor.
Is it just to enhance flavor? Are you also adding it to do functional immersion, or you don't want immersion to take place in hard candy?
Hard candy generally not much. Okay, immersion means small sample.
Oh, okay.
Hard candy means the
why then probably this is also a quality parameter that we need to measure. And why do we say inversion is not desired in terms of shelf life? What is the point?
Since inversion makes actually fructose.
Okay.
Fructose is not desired in hard candy, since when the fructose content in the hard candy or soft candy, the getting moisture availability from outside, getting higher, and when candy gets moisture from outside, the shelf life is increased. Okay, that's the main.
And also, when fructose hot candy starts to is of softening. And starts to be stick to your teeth.
Oh, okay. That's also not something that's
Yeah, you can understand without any measurement by the texture. It comes off the hot candy effect, immersion start.
okay. And also, just to make an explanation for those who do not know about the inversion, or why do we call it inversion? Sucrose, as being a disaccharide, is hydrolyzed into glucose and fructose in the presence of acid. And the term inversion comes from the fact that normally concentrate or this process is measured by polarimeter, and light is polarized in the other direction in the glucose and fructose mixture. So this mixture is called invert sugar. That is where the name inversion comes from. So in that regard, it may also be really a good strategy to monitor inversion in hard candy by using the techniques that we are implementing in SuChAQuality.
If you have any interesting questions or curious about something, would like to hear that later. This actually, in the kitchen, everything is logical, which we do, but sometimes we don't know actually, but sometimes we do not know what they are doing in a logical sense. That's the reason that we can explain all logics in that sense.
One question I have, so is there also a certain bricks or level that you want to achieve
In hot candy,
yeah, in hard candy?
it can be the loss, and there's some restriction for the hot candy. The hot candy cannot have more than 2.2% of total.
Oh, okay. So the maximum is 2.5%.
2.5, yeah.
Okay. It is the water content
Yeah, the final content.
in the final product. Okay.
But it's hot candy, there's no limitation.
And just one question. Normally, whenever you want to measure the moisture content of hard candy, what method do you use? Coefficient titration. So don't you measure the soluble solids as well by melting it or by mixing it with water? Do you also use that option?
In this soft candy, that water cannot be more than the hot candy, that can measure it on the performance. But in the hot candy, too much and less water, and both. But we will be not by temperature.
Okay. So why I bring out this point is coefficient titration is a method which requires iodine. So the chemicals are really not making the methodology very sustainable. So that regard, it is really important to develop methods to measure the moisture content of hard candy by using again one of the methods that we develop within the SuChAQuality. That may also help us.
So if you were to put that in a mold now, that would be soft and not a hard candy. Do one every minute.
Yeah. Actually, for hard candy, cooling is a very, very crucial process. Since we cannot cool down in a very specific time region, we cannot get the desired texture at the end of the time. For the cooking part,
Yes.
after cooking. Yeah, in the cooking. 135. 135 will be enough. Also, in industry, use of vacuum helps to get water inside of it, and then you don't need to cook in a much more long time. But by using vacuum and then steam pepper, it is quite easy to get actually hard candy from start state and maybe not more than 8 minutes. Actually, there are two different types of explaining vacuum in confectionery science. One is this kind of procedures like that. Make a dead bar vacuum until that temperature is reached. For example, we cook 120 Celsius degree, making vacuum maybe 0.5 bar up to 140 Celsius degree. The other method is time method, using vacuum, again 0.5 bar for 10 seconds. By this way, the temperature, when you reach the desired temperature, after that, the final not bounded water inside of the mixture, outside of the candy dough, can be get easily by using vacuum. We will get at the same time hard candy during the conditions, but you can actually watch each time at any time. By since the hard candy process is quite shorter than the soft candy process, we will get cool down, and then after the cooling is over, we will cool. If you need, you can attend also the cooling part, and then kneading and mixing the ingredients in the soft candy parts.
Some one question. What is crystallization in hard candies? We don't want crystal to form in hard candies. What causes crystal?
Okay, yeah, but we use the crystals in order to stop crystallization in hard candy. What is the part to crystallize it? Hard candy, you have to use crystal sign.
Okay. Otherwise, we will just obtain a sucrose crystals. It's like a crystallization inhibitor. It's the same thing.
Well,
No. Use the camera.
Now I'm preparing the flavor compound and the colorants, which will be added after we get the desired temperature. This is the citric acid. Strawberry flavor.
need to pull actually. Next step.
Eren. Ses geliyor mu?
This is not so
Actually, it is a little bit shorter time than we expected. This is the reason of the
setting too quickly now.
yeah.
How do you clean that afterwards?
Actually, for that, the hot
That
water
one.
is enough.
How do you clean that one?
Su problem olmayacak, sadece şekiller çok.
Try this at home.
It looks very nice.
You can touch also now. It's dense, but yeah, it is kind of that texture at the beginning. When we get cool it down, it is more brittle. It will be more brittle. Something like that.
What is the temperature that
For that, maybe 67. Maybe we can taste it.
Yay.
By the way, the color is the red color is directly extracted from the electrode. Yeah, in Turkey there are lots of electrode producers. Did you see the sound when it's full? It means that it directly goes to the amorphous state. Actually, in a few minutes, it it is ready to eat. For that also, we need to make energy.
Yeah, it's not as bad as the process.
But if you want, you can taste this.
It's tiny bit. Just a small one. Really low?
Starter, what ingredients we have here?
Actually, mostly starters. It's kind of maltodextrin, cornstarch, hydrate form of dextrose, and there are some liquid inside of it, orbital and glycerin. It actually helps to get the structure a little bit softer.
Okay, just let's go one by one. So why do we add maltodextrin?
Actually, any previous form of the glucose, the texturizing agents from the soft formulation, making a formulation with full of maltodextrin will not be enough to get desired level of the taste actually. So that's the reason we use kind of sugar, glucose sugar, and others. It's a very good material. It's both texturizing the soft candy, both providing much more sweet taste than maltodextrin.
Okay, then, well, we cannot exclude starch because it is the main jelly made, right?
Exactly.
And what type of starch do you use in such confectionaries?
For that product, we don't have to use a specified starch. Just
Okay.
cornstarch is okay for that product. Since cornstarch can inside it. So can also I forgot to say that there's a kind of saturated alcohol inside of the soft candy.
Oh, okay, why is this happening?
Since when you get the chewiness, it is very hard to maintain without oil based.
Oh, stick your teeth.
Exactly. Also, we use some kind of emulsifier type of product. It is GMS, ceramic cerate. This is also we can use lecithin and kind of other emulsifiers. Since in our formulation the fat content much more less than the other products which include emulsifiers, we don't use very much amount of emulsifier, but eventually we need to bind that polar structure and non-polar structure inside of the candy.
Okay. And what type of final product we will obtain here?
Actually, it is called topping in literature.
Okay, so happy confectionery then.
Yeah, it will be very cheap. You get that market in your mouth, you cannot chew that candy. You will just lick it. But soft candy, you will chew it. Yes, exactly. I mean, that's actually drop off this direct pieces. Okay, well,
Just one question. You probably don't want candy to be broken apart quickly. Like, so how do you control it? Like, what makes it really very fragile?
The soft ingredients.
Okay. Okay.
I will get the rigid parts from the candy in our production area.
Okay.
Building like that, the lollipop form or the other type of candies from little round shape to get it out. That's quite similar process which I will be done actually. To get rigid and the hard. Since our cooling process is not done actually very in a successful way, but the except of the shape of the candies, everything is quite good. As it is. If you want to get this more.
So I didn't know that. So there's like something that you need to do in order to prevent their break apart. Okay. Yeah, that's because like I know that the production line there is susceptible to like breaking apart.
Yours does break. Okay, but you're not going to tell us.
We can measure the maximum temperature of beer candy, other candies, and then we can understand what is happening. What I realized is that the actually I think TG is an important parameter, but normally it's not measured that way.
Yeah, exactly. TG directly relates with the shelf life of the candy. When we get, for example, high moisture content, high relativity environments, and the high temperature, candy is willing to start to melt.
Yep.
That's just kind of baking spray which we use in our kitchens to not get stick on the marble or soft candy base.
Okay, now we are gonna create a dough for the soft candy.
Yeah, exactly. We will observe that process in a much more detailed way, since it is a quite long process than hard candy process.
For 120. So that is proper. So you need to evaporate more so that it will be heated up more.
Başka maddeler var. Actually, if we use the sucrose and water, maybe we can get the crystalline in a more crystalline form. But that kind of hard candy is not considered as hard candy. Maybe you saw the
rock candy. Rock candy, yeah.
They are known. They are just made from sucrose.
Yeah, made from sucrose and water. It is much more variable, much more different texture. But in rock candy, it is very hard to make in the industry
Because it's not consistent.
Yeah, well, that's amazing. But in kitchen, sucrose and water will provide you kind of candy, very hard texture.
One question: what would happen if we do not bring the right temperature?
Yeah, we have this right temperature. The that comes over. The product is start to should have
Which is not something that.
yeah.
This is the flavor. Yeah.
But yeah, when it comes like at a certain distance, you feel it much better.
Like this distance, it is quite okay and quite refreshing, but in a very close distance, please, this is also very dangerous to get in terms of it is a very high concentrate flavors. That's the reason now the room is very good, very nice smell, but when you get inside, it's very close. Yeah, it's quite okay.
What's the percentage in the population?
Not more than 0.4%. It is very quite high concentrate, 0.4% gives a really good flavor in the dough.
Karşıya geçmem lazım. Mutfaktaki bu tencereye getir. At geldi.
Salt and I
Yes.
Uh,
In addition to flavor,
colorant and acid.
okay, color and acid. Yes. And acid is again for the flavor.
Yeah, for the flavor, this is icing. Yeah, in a very much more little particle size crystal. Just getting drunk.
Yeah, stick on the outside.
Yeah, soft.
Oh, I mean, do you also mix it with the dough?
Yes.
Oh, you know, not the outside. So they're also going to put it.
It will be in the formulation actually, and the cooling and the.
Why do you put it afterwards?
Actually, if we put beginning of the cooking, the texture we will show you about when we get into the pieces, we can see little crystals in the soft end. If we start at the cooking,
You did not see that.
yeah,
And
exactly.
you want to see these crystals. in
Exactly.
This.
To get the very nice mouthfeel and the chewiness.
That's when you add those.
And it is
After
like
But we
you're
should
chewing
make
this,
constant.
then you
So it's not anything. It's a little bit fine.
Yeah, the finest version as the of the crystal sugar actually.
This is it.
And so
It is actually in powder form needed is to get into the product in a very homogeneous way. But in some formulations that can be citric acid added in the liquid form. It can be possible, but that kind of products liquid form of citric acid will be increase the moisture of the final form.
Oh, okay. And you don't want to do that.
Yeah,
That's why
exactly.
you prefer to add it.
Yeah, if cooking states, it can be possible to add a liquid. This is baking soda. Yeah.
So it doesn't stick.
Yeah. Actually, it is
You just use it when you bake.
the only purpose of it to remove the stickiness part of the clothes.
You need to cool it down to what temperature now?
now the food nearly 80 degrees.
80.
Before putting on the marble. Okay.
When did you add these?
Maybe at the middle of the when we add the powdered sugar form. But this is not very effective final form of the candy. I think the sucrose is the most highest one, actually, most highest ingredient in the formulation, glucose. Then sucrose and other kind of bulk carbohydrates like starch and maltodextrin.
And some emulsifier. There's also one more.
Yeah.
To make it so that it will not stick to your mouth because it is chewy. They also add some semi-solids like palm oil.
Yeah.
So you add these as part of the kneading stick. Also added the yeast to it.
Yeah.
They added as part of the kneading stick.
Yeah, exactly.
So I think they will first add these two and later on the flavors.
Actually, after adding citric acid, we can add the
Flavor.
flavor.
Oh, okay.
Some kind of logistics.
İşçiler.
But I don't know any somewhere about questions.
This is publishing.
That's the book. Except when they are making it with different colors, they mix it and they wrap us in.
Oh, yeah, this is known as aeration process. They call it.
When you look at candy, it is quite yellow color. When the aeration and the kneading part is going on, it is getting whitish color with the help of also powdered sugar. Also, it is possible to make completely whitish color candy with powdered sugar. It is possible. Even it is, for example, colored at the beginning of that stage. After that, it can be whitish color. Maybe like to know some of you can. It's a very dangerous process. Yes. It is when you get into your candy, your finger. The worst scenario is stick candy and the cool down to the finger.
It's like super sweet.
Yeah. Yeah.
Did you tell me?
No, I don't. Every time we use that kind of gloves, resistant gloves to heat while we touch the can. It's very
What's the temperature?
about gloves.
No, like this blue. At the moment, what is the temperature?
What is the temperature
Oh,
of
what
the
is the
dough?
temperature? Check. I think less than 67. Yeah, but you 87, 87. So that's 37. Yeah, sometimes we can't understand the temperature while observing texture of it. And it was the flavor compound.
Colorant?
Yeah, color. For the orange color, we use paprika extract. Maybe some kind of products require annatto extract. Maybe we can add a little more. I will make pre-testing. Oh, yeah. If everything is going well. It's very sensitive.
Up to what point you when do you stop meeting? Up to what point you continue meeting?
A little, maybe 10 or 15 Celsius degree more than the room temperature. It will be. Let's measure. Çok az. Hadi. Now the best part is coming. Tasting.
Oh, you taste it.
Yeah, of course. The main purpose of the making candy. Actually, mostly children very interested about the making candy and the tasting process. When we get older, we are much more away from candies actually.
So nice. So it's not sufficiently cool.
Yeah, it is kind of maybe 40 to 43 Celsius. 48. So it's cooled down at this stage. After that, it is ready to taste.
In different machines.
Of course, we are not using our hands to get that form, but as you see, as you can see, it is very simple to make candy in the kitchen. Maybe for soft candy, you cannot find each ingredients like the starch-based ones, but for the simple ones, it can be achieved. I can see the air bubble. Would be a problem. For that, not be a problem. If you see the air bubbles with the hard candy, it will be probably because of the pouring. Since while pouring, it is directly contact with air, and the air is getting it. But the air bubbles doesn't consider as the problem in soft in actually mass production, there is no pouring step. There's kind of candy mass, and it is formed directly. In pouring type of candies, it is problem. Also, that kind of jellies, you can see air bubble. There's another quantum problem. Air bubbles inside of the jelly means that you cannot mix the candy dough very well, and then still air inside of it. It is possible. step to get to the film or black shading or something else. Perfect mix and the appropriate conditions of the pouring element. During the cooling step, in the cooking stage, as I said, there's kind of start with ingredients, glucose, sugar, sucrose, and then glycerol also. Yes, actually moisture inside of it, and the moisture inside of it to get the chilies. In that part, we use citric acid, powdered sugar, liver compounds, and no, there's no gelatin. When you taste that, it is quite good question. Since without gelatin, it is kind of gel form, that product. The starch and the other type of ingredients, start with ingredients, provides that jelly efficiency into soft candy. As you know, in a food science perspective, this is a gel. Yeah, but the jelly is like when we compare the other jelly forms and the gummy bears, yeah, this is the only jelly agent that product is starch.
Ingredient makes the difference between hard candy and soft candy.
For the rest part of candy, we will proceed with the high cooling rates. Yeah, not for your time. Since for the rest of it, we will cook that part. Maybe, yeah, better put it like. Towards the
Or we could have rolled the
actually, that is a quite nice experiment. See differences between hard candy. We cannot control the cooling process. It's actually immediately after we take that. But that kind of candy, even it is cooked up to 120 Celsius degree, 120 Celsius degree. Hard candy reaches 135 Celsius degree, but it is cooled down in a much more rapid way. Directly see the difference. Maybe we have lots of parameters, not consistent, but just saying that. Production of SuChAquality. We are using cubic tons, maybe 15 meters from cubic tons for this package. In the industry, this is much more shorter time than we experience now. Yes, right.
Oh, no.
Anyone who wants to speak, please come here.
I checked.
That's perfect for you. I can have some minutes. You mean like you mean
40%.
We got to break 30 hours.
yeah.
Yeah. Better than the ones that you get from the shop.
Yeah.
Much better than the ones in the package.
Precious memory. You can eat one. You want to cut? Is it like
Too much citric acid or other compound sugar rather than it is like it's that way, so that kind is right. Yeah, yeah.
He's more generous as well. He's more generous with his portions. Yes.
so my Jesus and the differentiation of the
I did try it now, right?
Yeah, no problem. Shivan says.
It's your turn now.
Stabilitesi nasıl? Mesela açık açıkta kalsa hemen şekerle mi gidiyor?
Buraya yerine de kalsa şekerlikten ziyade nem kapar.
Ah, that was my switch.
Ama paketin içinde
Yok. Mesela atıyorum şu an alsa akşam yesin. Salatlaşır.
sıcak olduğu için belki biraz
Yayılır.
onun haricinde ama tadında hiçbir değişim olmaz.
Yani tamam, o kadar hızlı nem çekmiyor. Ben aslına bakarsan yayılmasından ziyade sertleşmesine, hard olmasını falan, dışında bir kabuk olmasını beklerdim.
to get into the cutting process into the most safest version of the candy.
Yeah. What is it? Now it's all in candy.
bir de şekil yapmış.
Hele.
Yiyecekte şeker katıyor onlar.
Hadi boyayalım. Kutumu getir de koyalım. Falan. Neyim o? Daha çok double yolda ama sen bilirsin, ne olsun. Emeğine sağlık. Hadi yap. Hadi.
Çok zor. İşte ben böyle zor bir
You can get into your pants.
Elinle alsın. Kopar elini. Gözde Esma'yı çekin. Boyarken çek. Kağıdı. Çek. Hocam hırsız.
Geçtim.
Stop mu? Stop mu yüzünü? Yap. Kafe break. Ben kafe break için gidiyorum.
Yok kalp. Kalp yok mu? Nerede kamera? Ölmüş. Allah korusun. Hayır, Allah korusun. Aşkı da ölmüş. Aşk ölmüş. Doğru.
Hard&Soft.
Make an art. Glow verebiliriz belki. Ben gevşetmiştim. Yapayım mı? Yaparım. Yaparım ama istiyor musun? Ben pasta kesme şeyimle ünlüyüm de bir pastayı 16 kişi, evet, kaç kişilik olursa olsun 100 kişiye paylaşsın. Ama bilmiyorum tabii. Şekerde de. I can have them infinitely. Let's say many.
You always need that person.
sabitlesek daha iyi değil mi ya? Eren iyi tutmamış bunu.
Kimse yapmak istemiyorsa ben hepsini keserim.
Then you earn it.
So, coffee break will start soon. They can start that. So I think 3:30 we will have the chocolate. Yeah, 3:30 we will have the chocolate.
Your video.
Bilmiyorum, bir Eren'i çağırabilir miyiz? Başlamış.
Like 50 pixels.
Ay. Kapatıyorum ben bunu. Kapatıyorum şu an.
Zoom. Short presentation that he will go over, and I will be translating it in English. So we are ready to go. And
Herkese
then I may
merhabalar.
interrupt time to time.
Tamamdır hocam. Herkese merhabalar tekrardan. Toplantının hani son olarak bir çikolatayla, tatlı bir şeyle kapatmak güzel oldu hocam. Öncelikle teşekkür edeyim. Çikolatadan bahsedeceğim. Çikolatadan bahsetmeden hocam önce bir tören çikolatadan bahsetmek istiyorum.
Sure.
Tören çikolata 2003 yılında hocam çikolata sektörüne giriyor. Gaziantep'te %100 ihracat yapan bir firma. Müşterilerinin gösterdiği ilgiden dolayı çikolata, nugabbar, Hindistan cevizi ile ilgili ciddi üretimler yapıyor. Bu son 6 yılda %300 büyüme gerçekleştiriyor hocam.
Okay, so since 2003, SuChAQuality is carrying out its operations in Gaziantep, which is a city located in the southeastern part of Turkey. And they are 100% exporting company. And they are not only producing chocolate, but they are also producing wafers, nougat bars, cocoa bars, cream chocolate in tubes, and also they are producing some chocolate for breakfast. And in the last 6 years, they have grown 300%, so which is a huge growth. Yes, devam edebilirsiniz.
2022 ve 2023 yılında hocam son 2 yılda hatta pandemide başladı. Yapılan yatırımlarla 20 bin metrekare olan kapalı alanımızı 60 bin metrekareye çıkardık. Yani bir 3 kat daha büyüme gerçekleşecek. 2023 yılın sonunda, 2024 yılın başında. Buyurun isterseniz.
And by the end of 2023, so they will have almost 3 times of their current spaces. So they had made huge investment and increased their capacity from 20,000 square meter to 60,000 square meter.
2018'de Ar-Ge merkezi olduktan sonra Ar-Ge çalışmalarımıza daha disiplinli bir yönelme oldu. Ondan sonra işte projeler, Ar-Ge merkezinin kurulması, sizle tanışmamız. Bundan sonra Ar-Ge çalışmalarımız daha da disiplinli bir şekilde ilerlemeye başladı hocam.
And since 2018, they have been selected as an R&D center, which brings extra incentives. So this is something that is happening in Turkey. Some organizations can apply to be an R&D center, and they get some privileges from the government. Yes, devam
Ürünlerimizden bazıları, ürünlerimizin görselleri.
So Selçuk Bey, daha çok hangi pazardasınız?
Hocam dünyanın her yeri diyebiliriz. Ağırlıklı olarak Orta Doğu'da var, Afrika var, Arabistan var, Uzak Doğu var, Avrupa var, Amerika var. Yani dünyanın her tarafı diyebiliriz. Girmediğimiz birkaç ülke kaldı.
So I asked which countries are the products are. It says that literally all the countries we are in, but in Turkey, no, they are not in the Turkish market, but I think they can consider Middle East as being their first priority market area, but there are only a couple of countries left in which Tören products are not in yet. So they are mostly in
Türkiye'nin en iyi gofretini ürettiğimizi söylüyoruz hocam. Bilmiyorum tabii ne denir.
Oh, okay. So they are very confident on saying that we are producing the best wafer in Turkey.
Evet.
Okay.
Ürünlerimizden bazıları sağ taraftakiler çikolatalar, gofretler, gofretin her çeşidi işte dikey paketlemesi, yatay paketleme ya da işte meyve aromalılar gibi bayağı bir ürünümüz var hocam. Bunlar da görselleri.
A bunch of variety of products as you can see. So small wafers, regular wafers, and some other chocolates-like products that you see in the slide.
Evet, şimdi konumuza gelelim. Çikolata. Çikolata ile ilgili çikolata bir mühendisin çalışabileceği en güzel alanlardan birisi hocam. Bunu her türlü envai çeşit ham maddesi var. Yani kakaocu gibi kakaoyu bilmen gerekiyor. Yağcı gibi yağı bilmen gerekiyor. Prosesler çok kompleks. Konç prosesi, temperleme prosesi, işte refining prosesi. Çok yani bir gıda mühendisinin çalışabileceği en güzel sektör.
So he says that
chocolate industry is one of the best sector that a food scientist and engineer can work in, because it involves not only formulation studies, but also there are a bunch of different processes, since you have sugar in one side, but you are also dealing with cocoa butter, which is lipid based. So you have to know the lipids, you have to know the carbohydrates and so on. So a lot of different information are merged in this unique matrix.
Yani genel olarak çikolata olmazsa olmazı kakao yağı, şeker, süt tozu ve değişik maddelerin tekniğine uygun olarak karıştırılması, inceltilmesi ve kalıplanmasıyla oluşturuluyor. Türk Gıda Kodeksine ise bunların limitleri var hocam. Bir çikolataya, sütlü çikolataya çikolata diyebilmemiz için kakao kuru maddesinin en az %25 olması gerekiyor. Yağsız kakao kuru maddesinin en az %2,5, süt yağının 3,5 olması ve süt kuru maddesinin 14 olması gerekiyor. Bu olmadığı takdirde bu ürün sütlü çikolata değil. Türk Gıda Kodeksine göre.
Okay, so here you see the concentrations of the ingredients which has to be satisfied with respect to Turkish Food Codex. So according to this table, for instance, in order to classify a chocolate as milk chocolate, it should have cocoa solids at the minimum ratio of 25%, milk solid ratio of 14%, and milk fat 3.5%, and non-cocoa fats solids 2.5%, and in overall the total fat should be minimum 25%.
Evet. Bu aynı yine Codex Alimentarius'ta da aynı şekilde hocam. Sütlü çikolata, beyaz çikolata ve dark çikolata için. Yani bildiğimiz temelde sütlü çikolata, dark çikolata ve beyaz çikolata olarak 3 temel çikolatamız var.
Okay. Sizin resipi aslında normal kodekstekiyle Türk kodekste olmadı uyumlu.
Tabii
Okay.
tabii olmak zorunda zaten hocam.
Okay, so the ratios are also aligned with the Codex Alimentarius ratio, and their chocolate is classified as 3: white, bitter, and milk chocolate.
Bu yeni çalışmalarla beraber hocam kakao çekirdeğinin fermentasyon tekniklerinde bazı değişiklikler yaparak da Ruby çikolata diye bir çeşit daha çıktı. Görmüşsünüzdür. Bu yalnız tabii henüz eklenmedi. Yani 4. bir çikolata da denilebiliyor Ruby'ye.
Okay, and there are some processes which requires fermentation of the cocoa beans, which eventually transformed into a 4th type of chocolate, which we know as the ruby chocolate.
Peki bu kadar sütlü çikolata var. Bunların her birinin ya da bitter çikolata var. Bunların her birinden farklı lezzetler var. Tabii ki proses buna etki ederken burada kullanılan kakao çekirdeğinin çeşidi de ciddi manada etki ediyor. Toplam 3 çeşit kakao türü var. Bunlar Criollo, Forastero ve Trinitaro diye geçiyor hocam. Buyurun şöyle bırakayım.
Okay, so there are 3 types of cocoa beans, and that is why we can observe different types of flavor profiles in different chocolates. And these 3 beans are Criollo, Forastero, and Trinitario.
Bu en az üretilen Criollo, %5'lik toplam üretimin %5'ini kapsıyor hocam.
Okay, so the least produced is Criollo, which accounts for 5% of the total cocoa bean production.
Orta Amerika, Karayip Adaları, Güney Amerika'nın kuzey taraflarında üretilebiliyor sadece.
So in the northern part of South America, this is mostly grown, Criollo.
Forastero ise en fazla üretilen ve en fazla verimin aldığı bir tür olduğu için en fazla üretilen, en çok da tercih edilen bir kakao çeşidi, kakao çekirdeği çeşidi.
The most preferred one and the one that is produced more in terms of efficiency is the Forastero. And herhalde ikincisi de Trinitario oluyor.
Evet hocam. Trinitario'da ikisinin mix yapılmış, melezlenmiş hali diyebiliriz. Altta da görseller mevcut hocam.
So Trinitario is actually the hybrid version of Criollo and Forastero. So this is another type of the bean. Okay.
Resimler gözüküyor. Çikolatanın temel girdilerinde konuşacak olursak hocam, çikolata az önceki kodekste de bahsettiğimiz gibi çikolatayı çikolata yapan kakao yağı, kakao likörü, kakao tozu. Yani içerisindeki kakao girdileri. Bitkisel yağ kullanılamaz. Bunun dışında
no oil is allowed to be used in chocolate.
Yeah. Şeker ve süt girdileri. Bu süt girdileri de yağlı süt tozu, %26 yağlı. Yağsız süt tozu, sade yağ, peynir altı suyu tozu, laktoz reçeteye göre ya da ürüne göre değişebiliyor hocam.
Okay, so he listed here the cocoa raw materials, which are cocoa butter, cocoa liquor, and cocoa powder. So in order for a chocolate to be classified as chocolate, these are the three must ingredients that we should have. And then we have sugar. And if we are producing a milk chocolate, then milk, whole milk powder or non-fat milk powder, sade yağ. So
Anhidrous
ghee,
milk fat.
anhydrous milk fat, whey protein, whey powder, and lactose. So these are added depending on the formulation, but they are not must. Okay.
Tabii yapıyı sağlayabilmek için yağ ve yağın tüm partiküllerin etrafında homojen dağılmasını sağlamak için emülgatörler, lestin ve PGPR kullanılır. Aroma vericiler ve tuz. Çikolata ham maddeleri olarak kullanılmaktadır.
Okay. So here, this is like, I think, an important slide, because there we talk about the emulsifiers that are present in chocolate. We add lecithin and there is PGPR. Selçuk Bey, can we differentiate the function of lecithin and PGPR? What is the difference? Lecithin ve PGPR neden ayrı?
Lesitin hocam yağların fosfolipitleri, yağ sanayinin atık ürünü diyebiliriz. Tabii lesitinin emülgatör olarak görevi sınırlı kalabiliyor. Çikolatanın içerisinde lesitin miktarını eklediğinizde viskoziteyi düşürmeye meyilli. Belli bir limiteye yaklaştıktan sonra bu tam ters etki yapar hocam. Viskoziteyi yükseltir. Lesitinin böyle bir etkisi varken PGPR, poligliserol poligliseronat bizim tabirimiz ise bomba gibidir. Yani yağ 1 kilo PGPR'ı yaklaşık bir 7-8 kilo yağ denk getirebilirsiniz. Yani 1 kilo PGPR eklediğinizde 7-8 kilo yağ çekebilirsiniz hocam. Sanayi diliyle.
So azalta mı 1 kilo PGPR koyarsanız yağı azaltabilirsiniz.
Tabii yağ azaltabilirsiniz, evet hocam.
Peki PGPR'ın asıl function'ı, what is the function of PGPR?
Emulsifier.
Is an emulsifier, so it decreases also the viscosity.
Yes.
Viskoziteyi azaltıyor o da.
Viskozitede bizde 3 parametre var hocam. Viskozite, plastik viskozite ve yield value. Yield value çikolatanın non-Newton sıvılarda çikolatanın ilk akması için gerekli olan enerji. Plastik viskozite devamlı akması için gerekli olan enerji. Viskozite de zaten akmaya karşı olan direnci. Kaplamalı çikolatalarda hocam plastik viskozitenin düşük olmasını, yani devamlı akması gerekir. İsteriz. Kalıplı çikolatalarda ise plastik viskozitenin çok düşük olmasına gerek yok. Yield value'yu düşük tutup ürünün akmasını sağlayıp sonraki aşamada yani daha fazla yağ eklemene gerek kalmaz hocam. PGPR direkt yield value'yu etki eder.
All right, that's a good point. For chocolate, we talk about 3 rheological parameters: yield stress, plastic viscosity, and the regular viscosity value. Plastic viscosity, yield stress
value,
dediniz, bir de
yield value de viskozite. Akmaya karşı.
Okay, and the viscosity. So depending on what type of chocolate you are producing, you have to select the parameters accordingly. And PGPR and the use of lecithin enables you to arrange the rheological properties in the way you want for the specific chocolates. And in addition to these emulsifiers that are present in chocolate, we have vanillin and other aroma compounds, and salt is also added. So in all formulations do we have salt? Bütün formülasyonlarda tuz var mı?
Evet hocam.
Why do we add? Neden ekliyoruz tuzu? Why do we add salt?
Hocam tuz üründe diğer aromaların ortaya çıkmasını sağlıyor diyebilirim. Belli bir miktar. Böyle bir etkisi var. Yani kararında eklendiği takdirde tuzun çok ciddi aroma profilini geliştiriyor.
Okay. So it's quite
bizim kullandığımız tuz da şöyle bir şey söyleyeyim hocam. Normal bir deniz tuzu değil. Yine ithal ediyoruz biz. Kaya tuzu kullanıyoruz.
Okay. So the salts, the presence of salt enables to enhance the flavor. So it's like as a flavor enhancer, salt is added. So it should be used in the proper amount so that it will not be the dominating flavor. But if it is added in the proper amount, then it will be, as far as I understood, a really good flavor profile. Okay.
Bu da ürünlerin, hani çikolataların, beyaz çikolataların görsel olarak işte kakao yağı ve süt girdileri. Diğerinde sütlü çikolatada bir miktar kakao likörü, kakao yağı ve süt girdileri. Bitter'de kakao yağı ağırlıklı olarak, bunu Maren Hoca'ya hocam gösterebilirsiniz. Çok fazla likör kullanılıyor.
Yeah, that's what he says. This shows like the proportion of the different ingredients. So actually in this slide, so I think
kakao
here
yağı çok az diyordu hocam, hatırlarsanız. Bitter'de.
Oh, yeah, so for instance, this is like the amount of the cocoa butter. This is sugar, and this is the cocoa mass. And what is this one? O en alttaki bu bitter üçüncüsü galiba, değil mi?
Evet hocam, sağdan üçüncü olan.
So this is bitter chocolate, the one on the right, which we have. Do you see the mouse?
Dark chocolate.
This is dark chocolate.
Stay on the brown line.
Ağırlıklı likör kullanılıyor hocam. Maren Hoca hatırlarsanız şey diyordu.
Yeah. So the amount of cocoa butter is increasing from dark chocolate, milk chocolate, and then we have the most cocoa butter in white chocolate. Okay.
Çünkü çikolata yapabilmek için kakao girdisini artırmak da gerekiyor hocam aynı zamanda. Hem de reolojiyi sağlamak gerekiyor.
Okay. Okay, just can you go back to the he is actually talking about cocoa powder now. Let us finish this. Devam edelim Selçuk Bey, ondan sonra bir sorumuz olacak.
Tamam hocam. Kakao tozu, şimdi bu girdilerden ufak ufak bahsetmek istedim. Kakao tozu nasıl oluşturuluyor? Kakao tozu, çekirdekler toplandıktan sonra fermentasyon aşaması yapılıyor. Aşamadan sonra kurutma, temizleme ve kavurma aşamasından geçiyor. Kavurma aşamasından sonra bir ezilme, öğütme aşaması oluyor hocam kakao çekirdeğinin. Buyurun isterseniz.
Okay, so once cocoa beans are harvested, so they are first exposed to fermentation, and then we have drying, and then we have roasting, and then winnowing, which removes the shells, and or maybe the order can change. Kabukları ayırma roasting'den önce miydi, sonra mıydı? Orayı kaçırdım
sonra
galiba.
Hocam. Sonra.
Okay, winnowing is following the roasting, and then after you obtain the cocoa beans without shells, you extract, I guess, the cocoa butter, and the remaining mass becomes cocoa powder.
Evet.
Oh, okay. Yeah, because he's also in the production lines. Okay.
Ondan sonra bu öğütme aşamasına geçiyor hocam. Öğütüldükten sonra böyle çikolata gibi sıvı forma geliyor. Buna biz kakao likörü diyoruz. Kakao likörü oluşuyor.
Okay. So this is the original cacao bean that is milled, let's say, refined, and you have cacao liqueur, which is okay.
Kakao mes, kakao likör. Sonra bu kakao likörünü presledikten sonra hocam kakao yağı oluşuyor.
Oh, okay. So this cocoa mass is pressed to obtain the cocoa butter, and there you see the cocoa butter.
İki tür kakao yağı oluşuyor. Deodorize ve natural kakao yağı. Natural kakao lezzeti çok daha fazla olan, deodorize ise kokusu alınmış, rafine edilmiş.
Okay, there are two types of cocoa butter, natural and deodorized. Natural one it is intense cocoa flavor. Deodorized is refined version where you remove the volatiles. Okay.
Bu likör preslendikten sonra geriye kalan bu tabletler kırılarak kakao tozları oluşturuluyor.
And these cocoa mass then
yağ alındıktan sonra.
So once they are molded, so you see this cocoa mass molds which have their oil already removed, and then they are transformed to a powder form. And this is the cacao powder.
Tabii bu kakao tozları da alkalizasyondan sonra bir takım kimyasallarla alkali değeri yükseltilerekten ya da natürel olarak kakao tozları üretilmiş oluyor.
And there are different forms of cacao powder. you're probably familiar from that from your food technology courses, alkalized cocoa powder and the natural cocoa powder. In alkalized cocoa powder, there is usually, I think it is treated with caustic, right? Alkalize olan.
Yani diyebiliriz hocam. Potasyum karbonat gibi kimyasallarla alkalizasyon yapılıyor.
So with potassium carbonate, we alkalize, and the reason for alkalization, as you will all remember, we want to increase the pH so that Maillard reaction will develop, and Maillard reaction will introduce more flavor, so we will have a improved flavor in the cocoa powder.
Rengi kırmızıdan koyu kahverengiye böyle siyaha kadar gidebiliyor hocam. Alkalizasyonla alakalı olarak.
Okay, with alkalization, the color of the cocoa powder changes from like something dark red to almost black cocoa powder because it's literally Maillard browning that is occurring there. Okay.
Prosese geçtiğimizde hocam toplam bir inceltme, yani öğütme, konçlama, homojenizasyon, aromalandırma, depolama olarak sınıflandırabiliriz. İnceltme 2 aşamadan oluşuyor. 2'li silindir ve 5'li silindir. Konçlama, ıslak konçlama, kuru konçlama, homojenizasyon yine konçta yapılan bir proses. Aromalandırma da aynı şekilde konçlandırma yapılıyor. Sonra depolama, tankta veya paketlendikten sonra depoda.
Okay, so these are the processes for chocolate making. Refining and grinding is the first step, which is very important so that we decrease the particle size of the sugar so that you will not feel the sugar crystals in your mouth. And there are 2 steps for this. It can be done in 2 cylindrical rollers, and later on it is transferred to 5 cylindrical rolls.
Yes.
And the other step is conching, and conching can be 2 types, wet conching and dry conching. And the aim of conching, I think we will explain that more probably. The aim of conching
İleride de
is
anlatacağım hocam.
okay, it will to increase the flavor, and then we have homogenization, which is also done in conching, and then we add the aroma. Okay, let's look at the refining process.
En önemli parametrelerinden birisi hocam mikron. Mikronu 20 mikrona, yani 18-22 mikrona düşürmediğiniz sürece çikolatanın o ağızda o güzel hissi, erime profili, aromanın oluşumu, o yapıyı hiçbir zaman hissedemezsiniz. Yani olmazsa olmaz mikron 120-180 mikrondan, hatta kristal şeker kullanılırsa bu 1000 mikrondan 20 mikrona kadar düşürülmesi gerekiyor.
Okay, so one of the things that we need to do during chocolate processing is, as we said, refining. The goal in the refining process is to decrease the particle size to 15 to 35, like in mean 25 micron. And over there, Umur, can you show us the micrometer, which is over there? So this is a micrometer which is normally used to determine the particle size. And we start from 120 to 180. And until then we go up to levels like 25. If you use sucrose rather than icing sugar or castor sugar, then you start from 10 to 1000 micrometer. And of course, the refining time will be longer.
Onu da getir. Bizim yani genelde kullanılan çikolata öğütmede hocam 2'li silindir ve 5'li silindir olarak kullanılır. 2'li silindir ön inceltme. Dediğim gibi kristal şeker kullanıldığında 1000 mikrondan yaklaşık 120-180 mikrona kadar düşürülür. Bu bir ön homojenizasyon aşaması da diyebiliriz.
Okay, so this is like the first step is pre-refining. Here we use these 2 cylindrical rolls to decrease the particle size, especially if you start with raw sugar from 1000 micrometer to 120 to 180. So that is pre-refining. And then we transfer to major refining.
Sonra 5'li silindir dediğimiz asıl inceltme ve homojenizasyon yapan bir makine. Burada mikronu 15-22 mikrona kadar düşürüyoruz hocam. Girdileri toz formundan yani 2. silindirden gelen 150-180 mikronluk ürünler 15-20 mikrona kadar düşürülür. Burada silindirin bundan sonraki slaytta göstereceğim. Sıcaklık farkıyla silindir üzerindeki kaplanmış çikolata her bir silindire transfer edilerekten mikron düşerekten en son silindire kadar çıkar. Oradan da çelik bandın üzerine dökülür.
Okay, so here in this 5 cylindrical roll system, so gradually we decrease the particle size on average to 15, but later on we will see in our demonstration here, we have merged this pre-refining and the refining processes just in all this melanger, which is just a single instrument. But in industry, we use these 2 different rollers to perform pre-refining and then the refining. And then in the next slide, we will see that.
Mikron ölçümünde de hocam şunu da göstermek istiyorum. Böyle bir cihazımız da var. Burada da partikül dağılımında görsel olarak bir yorum yapabiliyoruz. İsterseniz ileride şeyini de paylaşabilirim.
Okay, I think I know that this is something related with also viscosity. Daha viscosity ile ilişkili bu senin.
Sadece viskozite değil hocam, burada bir mikron da ölçümü yapıyor bu. Yani
Yeah, it has like a ruler something like that.
Aynen.
So you squeeze it, sıkıştırıyorsunuz ya.
Evet. Bu sol tarafta gördüğümüz bu ikili silindir, sağda gördüğünüz beşli silindir. Bu beşli silindire giren çikolata hamuru buradan sıcaklık farkıyla her bir silindire, bu silindirlerin araları da her birinde daha da kısadır hocam. Yani 150 mikrondan 50 mikrona, 30 mikrona, 20 mikrona kadar düşüyor. Bu her iki silindir arasındaki sıcaklık farkından dolayı çikolata hamuru birbirinin arasından silindirlere yapışaraktan konca gönderilir. Şu da silindirin çıkışı.
Yeah, the particle size is decreased. Selçuk Bey, normalde her silindir farklı bir ısıda mı, yani öyle mi ısıtıyorsunuz? Öyle bir ayar mı var yoksa?
Reçeteye göre, yağına göre değişir hocam. Yağ yapısı ve reçetesine göre değişir. Yani
ama
değişebilir.
Yani ısıtıyorsunuz orada sonuçta.
Tabii mesela örnek veriyorum. Şurası 28-30 derecedeyken şu iki silindir, burası 42'lerde, şu 60'larda, bu tekrar 30'lara düşer.
Oh, okay.
O delta T farkıyla ürün transferi sağlanmış oluyor hocam.
Okay, in these cylinders, there are different temperatures. So they are heated to different temperatures. So this temperature difference also enables for the particle reduction. So each cylinder is warmed up to different temperatures. Like in the 2 cylinder, in the pre-refining case, we are talking about 28 Celsius. Later on, in the 5 cylinder, we are talking about 60 in one, then 30 in one, and 28 in one. Okay.
Bu da farklı öğütme teknolojiler hocam. Mesela şu Wiener dediğimiz bilyalı öğütücü ya da bu Wiener marka, bu başka bir marka. Bu yine yatay bilyalı öğütücü, bu dikey bilyalı öğütücü. Şu bizim laboratuvar tipi kullandığımız bilyalı öğütücünün içerisindeki genelde bu dikeyde 9 milim çapında bilyalar kullanılır. Yatayda 0,5 milim çapında bilyalar kullanılır. Şu da melanjör, Meran Hoca'nın.
Okay, so there are different types of refining instruments in addition to the cylindrical rolls. One of the 2 instruments that you see over there are ball mills, and depending on whether it's horizontal or vertical, the diameters of the balls differ. And the one on the bottom is melanger, which is the one that we already have. This is also used for refining purposes. Okay.
Konçlama da yine farklı aşamalardan oluşur. Ürünü besleme, karıştırma, havalandırma ve rheoloji oluşturma diye hocam. Burada asıl önemli olan çikolatanın içerisindeki nemi uzaklaştırmak. Çikolata ilk girdiğinde yağ miktarı yani yaklaşık %50, yani içerisine koyduğumuz yağ olarak düşünürsek %50 daha az yağ girer, kuru bir yapıda girer. İlk aşamada sıcaklıkla yükseltilerek serbest olan yağla sarılmamış partiküller serbest olduğu için sıcaklık kaynaklı nemi çok daha rahat dışarıya atabilirler hocam. İlk aşama nem atma aşaması diyebiliriz.
Burada sıcaklık kaç derecelerde?
60-70 arası hocam. Bu da yine reçetesine göre değişir.
So from the refiner, the first stage, conching involves different steps. The first step is decreasing the moisture content. That is why the chocolate, which is coming from the refiner, is heated to something like 60 Celsius, and the moisture content is reduced to from 1% to 0.5 to 0.8%. And moisture content is important in order to achieve the desired viscosity, And also it is important to determine the amount of cacao butter that will be added at the last stage.
Evet.
Yes. Devam edebiliriz.
Ondan sonraki aşama uçucu bileşiklerin uzaklaştırılması. Hocam bir dakika. Dayana.
Okay.
Şöyle. Uçucu bileşikler yani çikolatada buruk tat veren bazı aldehitler, asitler bunların ortamdan uzaklaştırılması gerekiyor. Bunların erime yani noktalı sıcaklık buharlaşma noktaları çok daha düşük olduğu için konçlama prosesinde o sıcaklıkta karıştırma, havalandırarak koncun üzerinde açıktır. Karıştırma sırasında uçarlar hocam ve bu kötü koku, kötü lezzet dışarıya çıkmış olur.
Ya bu 60 derecede belli bir süre mi tuttuk? O zaman
hocam giriş 45-50 dereceyle başlar. Sonra 67 derece 70'e kadar çıkar, hatta 75'e kadar çıkar. Bu süre yaklaşık reçetesine göre değişir. 6 saat, 8 saat, 10 saat uzayabilir.
Yok, uçucu bileşik kısmında hala 70 derecede miyiz?
Evet,
onu
70 derecedeyiz hocam.
So then in the second step, so we are still at the high temperature. Now we are letting the undesirable volatiles to evaporate. So these are usually the components which are not desired in the final chocolate, which includes aldehydes, acetic acids. So with the evaporation of the moisture, so these are also removed from the chocolate. Okay, we can go on.
Sonra homojenizasyon aşamasında çikolataların içerisindeki fazla nemi uçurduk. Sonra yapının sağlanması gerekiyor. Şeker ve kakao partikülleri, süt partiküllerinin tamamının bir yağla sarılması gerekiyor hocam. Burada bir reolojinin oluşması gerekiyor. Bunun için içerisine eksik olan emilgatör ve yağlar eklenir. Reçetede eksik olan emilgatör ve yağlar eklenir hocam.
Okay, so we now are at the third stage, which is homogenization. We want this milk powder, other powders, sugar to be coated with oil droplets, the fat droplets, and that is why this is like a homogenization step. And depending on the formulation, here we add emulsifiers if needed. So like lecithin is added depending on the viscosity and depending on the final product. Okay.
Aroma geliştirme. Yine burada hani içerisinde kötü kokuları uzaklaştırdık. O buruk lezzeti, o polifenolları ya da işte asitleri, aldehitleri uzaklaştırdık. Böylelikle çikolata istenilen lezzeti yakalamış oluyor. Yani kakaonun lezzetini daha iyi bir şekilde almış oluyoruz. Ayrıca süt proteinlerinde yani daha doğrusu süt şekerinde ve içine eklediğimiz şekerlerden Maillard reaksiyonu da gerçekleşerek hocam böyle bir karamelize tat oluşur aynı zamanda.
Okay.
Böylece aromayı tam geliştirmiş oluyoruz.
So still we continue this conching process, and since we have also milk powder and we are talking about temperatures around 70, we induce more Maillard reaction, and Maillard reaction introduces more flavor for the milk chocolate. So this is this aroma improvement stage is also letting chocolate flavor to develop.
Evet hocam. Konçlama prosesi. Konçlamanın içerisinde böyle 3 tane kol vardır hocam. Bunların her biri birbirinden bağımsız döner. İkisi sağdan sola ya da soldan sağa dönerken bunu da yine aynı şekilde sağdan sola döndürürsün. Böylelikle homojen bir yani çok iyi bir havalandırma, çok iyi bir karıştırma olur.
Okay, so we have 3 blades as you see in that schematic. So with this design, it enables like this aeration for moisture removal, for the aroma removal, and also for improvement of the flavor. And on the right figure, you also see how it looks like in the presence of chocolate. Okay.
Burada da yine konjum prosesi. İlk besleme aşamasında kuru, nemin uzaklaştırıldığı, havalandırıldığı kısım. Plastik faz yine çikolatanın partiküllerin içerisindeki yağlarla kaplattığı reolojinin oluşturulduğu. Son sıvı faz ise emülgatörün de eksik yağın eklenerekten viskozitesinin oluşturulduğu, reolojisinin oluşturulduğu aşama hocam.
Yani aslında hep kuru ve sıvı
tabii beraber yapılıyor. Kuru konçlama, sıvı ıslak.
Değil mi? Yani prosesin içinde oluyor kendiliğinden.
Evet hocam.
Okay, so we start with actually like a dry conching step, and then we are following with the towards the end of the process, we have the wet conching process. Okay.
Bu da tamamlanmış ürünün viskozite sonuçları. Casson modeline göre hocam 2 RPM'de Brookfield'i kullanıyoruz. İşte 1, 2, 4, 6 RPM'de ölçüm yaparaktan kendi bir hesaplama yapıp bize viskozite, plastik viskozite ve yield value veriyor.
Okay, so here this is like final quality stage. So in order to determine whether our chocolate is ready or not, so it is a viscometer is checking whether it is fitting the Casson model parameters. Again, food scientists and engineers will know that in terms of the rheological model, chocolate behaves to Casson model. So it's like a modified version of the power law model. So if it is on the desired range, then we say that, okay, our chocolate satisfied the criteria.
Evet. Temperleme. Niçin temper yapıyoruz? Parlak bir yüzeyin oluşturulması, kalıplara dökülen çikolatanın büzülüp kalıptan daha rahat çıkması, dokunulduğunda hemen erimeme, daha dayanıklı bir, ısırıldığında veya kırıldığında çok güzel bir ses, ağızda erime profilinin oluşturulması veya raf ömrü için dayanıklılık oluşturulması için.
Okay, and after conching, which is the step that we will also show you today, is the tempering. Tempering is done to obtain a shiny appearance and in order to get the chocolate from the molds easily. So again, we need a good tempering. And when we touch a chocolate so that it will not melt right away, again, a good tempering is important. And one of the other important criteria is this good snap sound. I always give that example in my courses. The Magnum ads, usually there's a very beautiful lady. She just has a bite and the sound is just a huge crunchy sound. So that is a good tempered chocolate. Yeah, it's like a snap. So probably that's something we are gonna experience. And chocolate should also melt in your mouth at the proper temperature of 37. And also tempering is done so that it will not, we will not observe fat ballooning. So the fat crystals will not migrate to the surface of the chocolate, and we will not have this undesirable whitish appearance. So that is important for the chocolate. Okay. Let's move on. Devam edebiliriz.
Temperlemede hocam birazdan temper makinesini şöyle göstereyim. Temperlemede ürün 45-50 derecede ısıtılır. İçerisindeki bütün yağlar likit forma getirilir. Sonra kristalizasyon aşamasına kadar soğutulur. 28-30 dereceye kadar. Sonra istediğimiz formu yakalamak için 27 derece, yani bu beta 5 formunu yakalamak için 27 dereceye kadar soğutulur. Sonra içerisinde bu stabil olmayan yağların, stabil olmayan kristallerin de erimesi için tekrar 30-32 dereceye kadar ısıtılır. Böylelikle stabil, yani beta 5 form ağırlıklı bir kristal yapı sağlanmış olur.
Okay, so this is something that we talked about a lot in the meeting. So we're talking, and Umur mentioned also, Hilmi also mentioned in their presentations. So we're talking, and Naomi and Kari also mentioned. So tempering is like a temperature cycling process. So we have heating and cooling cycles, and we are going to also talk about these temperatures again while making the chocolate. Here you see the tempering machine. Buyurun Selçuk.
İki türlü temperleme yöntemi hocam. Bu klasik endüstriyel temperleme. Bu da süpernova dedikleri. Burada temper, az önceki bahsettiğim gibi temper sıcak bir de şeyle 45-50 derecede girer. Sonra soğutma yapılır. Sonra tekrardan stabil olmayan kristalleri eritmek için 30-32 dereceye kadar ısıtılır, gönderilir. Buradaki şunda ise şurada bir süpernova dediğimiz süper kristalizasyon bölgesi var. Çikolatanın tamamını soğutmaktansa burada beta 5 formunu yakalayıp altta 33 dereceye kadar soğutulmuş da karıştırılır. Buradaki amaç enerji maliyetini biraz daha düşürmek. Yani çikolatanın tamamını soğutmaktansa bir kısmını soğutup masada temperler gibi hocam sonradan temperlenmemiş çikolatayla bir nevi mayalama yapmak.
Oh, okay. So the left one is the traditional tempering, which is the regular tempering cycle we mentioned. And the right one, it is called supernova, you said. So
Evet.
it is like mixing the chocolate with the already cold one or heated one.
Evet. Yani.
Okay, so this is something that we can tell. Oh, okay, supernova is here. So
Mhm.
in the traditional temper and in the
Evet.
supernova form. So supernova form is just
Daha homojen de
to
diyebiliriz
save
hocam.
energy. To save
hı.
energy.
Hı hı. Kalite problemlerinden de bahsetmek istedim hocam. Şeyden. Kalite problemleri genelde nem, renk, su aktivitesi, erime problemi, rheoloji, partikül boyutu ve duysal analizler. Nem zaten mikrobiyolojik, rheoloji ve duysal özellikler için olmazsa olmaz.
Bir önceki slayda bir tekrar. Okay. Color, moisture, water activity, melting profile, rheology, particle size, and sensory profile are the quality parameters that we need to be careful about chocolate. If they are not controlled, then that could be a quality problem eventually. Okay.
Aynen abi.
Şimdi devam edebiliriz.
Evet. Şöyle. Nem hem çikolatanın çok şeyle düşmanı diyoruz hocam biz. Rheolojiyi bozduğu için yani çikolata üzerinin içerisinde nemin arttığı takdirde o ürün tamamen blok halinde kilitlenebilir. Ayrıca mikroorganizma, mikrobiyal gelişimi için de çok önemli olduğu için bizim için çok kritik bir problem.
So moisture is very important. It is like one of the most important enemies of chocolate. It is important for the rheological properties, microbiological properties, and sensory properties. So if moisture content is high, microbial deterioration could be likely. And in addition, the product could be transformed to a muddy texture. That is why we also do not prefer high moisture in the chocolate. And also it affects the rheology in a negative way.
Su aktivitesi bu da yine mikrobiyal gelişim için bizim için olmazsa olmaz parametrelerden bir tanesi. Normalde 0,4-0,45 civarında bir değerdir. Bu ortamın işte nemli olması ya da konçlama aşamasında ürün üzeri açık olduğundan o ortamın ıslak kalmasıyla yükselebilir. Bu da bizim için yine önemli bir kalite parametresi.
So water activity should be below 0.40. If it is not, if it is higher than that, then we are going to again experience some quality problems in the chocolate.
Evet. Partikül boyutu ilk başta da bahsettiğim gibi çikolatanın yeme keyfini oluşturan en önemli parametrelerden birisi. Mikron çikolatada 18-20-25 mikrona maksimum 22 aslında olması gerekiyor. Ürün formülasyonu, emisyon yapısı gibi birçok faktörden etkileniyor hocam. Ayrıca ürünün akış özelliğini, akma yapısını da, rheolojisini de ciddi manada etkiliyor partikül boyutu.
The desired particle size is around 18 to 25. It affects a lot of quality parameters. It affects the rheological properties, specifically the flow behavior. That is why we want chocolate to stick on to that 18 to 25 micrometer range.
Rheoloji yine çikolatanın önemli parametrelerinden birisi. Eğer rheoloji istenilen profilde sağlanmadığı sürece, örnek veriyorum, kaplamalı bir üründe plastik viskoziteyi yüksek yaptığınızda o ürün akmayacaktır. Ürünün yapısı değişecek, şekli değişecek, gramajı değişecek, soğutma prosesi iyi çalışmayacak, fet bulumu olacak gibi sonuçlar doğuracağından rheoloji de bizim için yine önemli bir kalite parametresi.
Especially if you're talking about chocolate as a coating material on a product, rheological properties become so important because it is flow behavior will affect its coating ability. That is why we have to control it carefully. Okay.
Renk yine ürün müşteriyi etkilediği için olmazsa olmaz bir parametre hocam.
Color is also important and it depends. It also affects.
Erime profili, bu da yine temperle alakalı bir kalite problemi. Çikolatanın erime profili, yağ miktarı, kristal yapısı, kristal boyutu ve dağılımıyla etkili hocam.
Melting profile is important and it's affected from the type of the crystals present in the chocolate. And in addition, we should have a melting temperature around 35 to 37 Celsius.
Duysal özellikler yine çikolatanın görünüşü, tat, ağızda hissi, aroma, ağızda erime profili. Bunlar duysal olarak değerlendirilen kalite parametreleri.
Sensory profile are also important for the overall quality of the chocolate. So appearance, mouthfeel, so these have.
Burada da yine fat bulunun ilgili, yağ kusması ile ilgili görseller, şeker ve yağ kusması ile ilgili görseller eklemeye çalıştım hocam.
So we have
Zaten
fat bloom and sugar bloom here. So which occurs, especially fat bloom occurs in improper tempering. Şeker kusması hangi durumda olur Selçuk Bey?
hocam soğutma aşamasında eğer çiğ point dikkat edilmediği takdirde üründe bir nemlenme oluşursa şeker eriyip yüzeye çıkıyor. Sonra tekrardan o soğuk uzaklaştığında yüzeyde bunun gibi böyle çiçeğimsi görüntüler oluşuyor.
Okay, so during the cooling stage, if we are not careful about the dew point, then condensation could occur on the chocolate surface, and then that could dissolve sucrose, and then once water is evaporated, the sucrose crystals will appear on the top, which goes sugar bloom. So that's also
Yine
another
yağ
type of
kusmasının
quality.
görselleri hocam.
And these are also some other photos of fat blooming.
Bu da böyle bir bitter çikolatada bir çalışılma yapılmış. İşte 18 mikron, 25 mikron, 35 mikron ve 50 mikronluk ürünler 0. saat, 24. saat, 48. saat, 72 ve 96. saatte ürünler bekletilmiş ve burada da şöyle büyütüldüğünde sıvı yağ kristalleri, kakao kristalleri ve yeniden kristalize olan yağların yapısı gösterilmiş hocam. Bunu da eklemek istedim.
It's a very interesting outcome. So if the particle size is not properly controlled, then we might have crystallization within the chocolate later on. So that is why particle size has to be on the desired range of 18 to 25.
Evet. Bu kadar da hocam, yordum sizi.
No, thank you very much. So thank you very much.
Ben teşekkür ederim hocam.
So Selçuk Bey, now we are going to temper a chocolate, but I mean, if possible, we want to keep you here because if there are any questions, then we are going to address our questions to you. Is that okay?
Tamamdır hocam.
Okay, thank you so much. So now, well, what we have done is Umur already prepared the formulation. Maybe he will talk better. And then it is this instrument, this melanger is like acting like both as a refiner and conching, but in fact, this is not a real conching because we are not heating it up.
Also, this is basically a grinder. The main aim is to reduce the particle size of the sugar crystal. Normally, because we have a particle size grinder, it starts from we use icing sugar. It starts from 100 micron, right? It starts from 100 micron, and do you want to check right now?
So we started from 100 micron, and now we are going to check with that micrometer to see whether the particle size decreased. Oh, be careful.
I can't explain it. Basically, squish the chocolate and measures the high particle size in the chocolate in the sample.
So you can just
Ama
see.
güzel olmuş bu yöntem. Bunu biz de yapabiliriz arkadaşlar. Biz elle yapıyoruz.
Oh,
Bence
okay.
yukarıdan sıksa daha şey olur.
Yeah, 3 times they did it. And can you show the value which is, Eren, can you bring the camera to the value which is read is over there?
92.
Okay, so 26. Acceptable, Selçuk Bey? Is it acceptable?
Yok. Değil hocam. Maalesef. Devam edelim.
Selçuk
Okay.
Bey 26 geldi sanki.
26 mı geldi? Kaç geldi?
26.
26,
Evet,
26.
Yine çikolata için yüksek. Yani mümkünse 22'nin üstüne çıkmamak gerekiyor.
Oh, okay. If possible, I mean, we don't want, he says that we better keep it around 22.
Bir de
Okay.
Normally 20 is the best value to not realize the sugar crystals in the chocolate, but if you have a good sensor analysis, you might realize after we ate chocolate, we will prepare in a minute, and you can take a chocolate and spread your palate of your mouth, and if you feel that sugar crystal, you have a good palate.
Okay.
And normally this process should take around at least 6 hours, but we are doing it like which is set to UK time. But 26 is the acceptable limit for chocolate, and this will be the first time. And then we will help. We'll measure the chocolate, the liquid chocolate in NIR device. They will bring it from the South Africa.
Oh, okay. So we will also make an NIR measurement for this to obtain the spectra. Okay, that's cool. Okay, that's cool. Okay. Just to remind everybody, Naomi and Carly are going to carry out their master thesis on chocolate, and they are going to, one of them is going to work on effect of crystallization, and one of them is the particle size, and they are going to use NIR to determine the quality parameters by using NIR. So this NIR instrument has been brought from South Africa. It's a good resolution one, I guess.
That's what they need to go. You need to
Is it enough for to
You need to close.
Yes, I need a spoon or a bigger change. That would be easier. I think it's more possible. Normally, this SuChAQuality mentioned 2 different steps. One of them is refining, which reduces the crystal size of the sugar crystals, and this is actually combination of the conching and the refining.
Okay, and then maybe you can take the NIR and go over there.
So we already did the adult current and the reference scan, so now we can get off. We the adult current and the reference scan, now we can make the salt scan, and we usually scan each 5 times at different places.
And each measurement is 100 scans.
Oh, okay.
Yeah, so each one actually keeps it there, it scans 100 times. Yeah, so each of the individual 3 measurements actually does 100 scans. So while it's scanning in one spot, it scans 100 times and averages to reduce the noise.
What are we expected to see by doing that measurement?
Okay. With this, you first get an average spectrum. If, say, we've calibrated or developed a model, so say Carly's finished her work and she's developed a model to predict particle size, we should be able to predict particle size.
Okay, we know the particle size.
Oops, yeah.
We know particle size, but right now we can compare right now.
Not at the moment, no, because to calibrate, you need to do at least, say, up to 100 scans.
Okay,
So you
right
first
now-
have to develop. So right now with the one spectrum, it just gives you an idea what this chocolate spectrum
It
looks
should
like.
be around our particle size.
This one.
The result should be.
Yes.
Kaç çıktı?
But it couldn't calculate this thing.
Yeah, rather than using the micrometer, our goal is just to use this NIR to predict the particle size. So that is the goal. Okay.
But you see, you can get some information. So I can't see the things now. Maybe I'll-
Artık sonucu ne çıktı?
Oh, okay, so we're there.
So that's one. So you know approximately what absorbs that. I'm having to look up at it now. You know, the one is moist and gradual and the mechanism and for starch, I think around 1200 is yes, it's just
Yeah, I think it's time to switch to the tempering. Okay, so assuming that our particle size is in the desired range, now we are going to start tempering. But as Selçuk Bey mentioned, normally we should start tempering at like 45 to
50, 50.
Above 40 is okay for us because it's enough to melt all the crystal, because the highest melting point crystal is type 6 crystal, and that was 36.3. It should be 36.3. And we are around right now 44.5.
Okay.
In the manager. We can keep going to temper our chocolate. There are two ways to temper chocolates. One of the handmade chocolate, Turkish sugar will help us to handmade chocolate, and we also have a tempering machine. This tempering machine, actually, the idea of both are exactly the same. Tempering machine automatically increase the temperature and decrease it and increase it again. And the handmade tempering we can do with hand or an air blower.
Okay.
I just want to mention something. So while going back to the NIR measurements, so the one thing that NIR is used currently in the chocolate industry is to measure the fat content. So that's the one thing they always do with NIR. So all their fat content measurements is done by NIR. Currently, as far as I know, not for other measurements. Yeah.
Okay. So Selçuk Bey, you were talking about that. Maybe you heard. So NIR is currently used in chocolate industry to measure fat content. Yeah. So that
Ben
is
de onun
something that
sonucunu
we can
merak
also
ediyorum hocam. Hem mikron anladığım kadarıyla partikül boyutu ölçüldü, hem de aynı zamanda yüzde yağ mı ölçüldü?
No. I mean, şöyle, normalde Marena hocaların çalışması şu an sadece parçacık boyutunu belirlemek üzerine, ama aynı anda eğer yağ içinde kalibrasyon yaparsak yağı da ölçebiliriz. Yani aynı matematiksel modelle NIR'dan elde ettiğimiz hem yağ içeriğini hem de parçacık boyutunu ölçmüş olacağız.
Çok güzel olur.
Öyle bir şey var. Okay. So
our stones are, these stones are really heavy and they help to crush the sugar crystal. And I am hopefully transfer my chocolate to temper machine. This is the temperature probe. It measures the temperature of the chocolate, the sample inside it, and it gets air from outside and heat up or just give the direct heating to the chocolate, to the bowl. That's our baking chocolate. I put my sample in the temper machine and we have to select our chocolate type. This is a dark chocolate. It's a really high quality dark chocolate. It contains more than 40% of cocoa butter and 40% cocoa and 40% sugar. It might be dark for the people who doesn't like dark chocolate, and I am making dark chocolate, and it automatically the set temperature is trying to be achieved, which is 42, and right now it measures 46. After it measures 42, it drops to temperature around 29. You have a chocolate. Then it should increase the temperature a little more to remove all the unstable and unwanted crystals. Then after that, our chocolate will be ready. I think we want to, I think we are ready.
So again, we are going to use marble because it enables us to cool the chocolate better. So
Dayana takip et bakayım.
Bakıyorum.
and this is But you are so much artistic.
Or maybe getting. Right now, chocolate is around 38 degree, I think.
It's okay. I mean, I can. Ben sandım bunu diyorsunuz. So it may cool down quickly.
32.
Another, a couple of points you may get.
32.5%. It's around 32, I think.
So now our goal is to decrease it to 27,
Yes.
right? Okay.
9 or 28 because I guess by making with hand, it's enough to actually. So we can try 27 or 28.
Okay,
Can you
20
check?
So that range will be
It's already 29.7.
Okay.
It cooled down because of marble.
Okay, I'm going by so.
Oh, you're not going to heat it again to,
No, actually, I learned like that in Japan, so I'm doing now like that.
so we skip that reheating process.
Yes.
And we see the difference between reheat and iron.
What?
If we reheat it and make the other process, can we see any change in
But it doesn't give us like, for the time being, we are not working with a model yet. So, but probably the spectra will change.
I'm doing because we need to get rid of bubble inside the chocolate. Again, I learned like that in Durukan. Okay, I guess ready to increase temperature, actually decrease temperature. So I put through fridge.
Okay.
Now.
Cool down.
Yes,
so that-
exactly.
Okay.
And it takes it. Evet hocam.
But still, okay. So what we had was,
I'm so excited. And I am not multitasking, so I am so sorry. Okay, thank you.
Selçuk Bey, I have a question. So what, I think we missed a step here. So what we had was we just decreased the
Tekrar bir
27 and then
ısıtmak-
put it to molds.
Biraz daha ısıtmak gerekecekti hocam. Stabil olmayan kristalleri yok etmek için. Mesela bizim orada uyguladığımız aslında Dayana da bahsedebilir. Dayana da burada. Bizim uyguladığımız yöntemde çikolatanın 1/3'ünü sıcak formda bırakırız. Kalan 2/3'ünü 27 derece, yani çikolata tipine göre 27, 26, bazen 25,5 dereceye kadar düşürdüğümüz olur. Düşürürüz. Ondan sonra tekrar ısıtmak için kalan 1/3'lik kısımla iyice karıştıraraktan stabil olmayanları da kristalizasyonlar, onları da bozduktan sonra yaparız, kalıplamayı yaparız.
Okay, so yeah, that's a good point that Selçuk Bey mentioned. Normally, still, for instance, in the chocolate that Melek made, we could have some unstable crystals. So in order to get rid of all the unstable crystals, another strategy could be the supernova effect. We could have added the already warm chocolate, like we put 2/3 of the chocolate to the marble. We let it to cool down to 27 Celsius, and then mixed 1/3, which is warm, to heat it up to 31 Celsius. And then at that point, we put to the mold, and at that stage, we will have the stable crystals.
Ayrıca hocam mesela o temperleme, mermer üstüne temperlemede kullandığımız spatula biraz daha geniş, belki Dayana gösterebilir. Geniş bir
Göstereyim
spatula
Selçuk.
vardır. Homojen bir şekilde, yani çikolatanın her yerinin aynı kalınlıkta olması lazım ki mermerde bütün her yerinin eşit miktarda soğutulması gerekir. Anlatabildim mi?
Daha geniş mi olması gerekiyor dedin?
Dayana gösterecek şimdi hocam size. Kullandığımız spatula orada ince uzun. Şimdi gösterecek arkadaşlar. Şöyle bir spatulamız var hocam.
Oh, okay.
Onu kullandığınız zaman çikolatayı mermere daha homojen yayarsınız. Yani bir taraf kalın, bir taraf ince olduğunda çikolatanın bir tarafı soğurken bir tarafı soğumayabilir.
Okay. So that's a good point. So Selçuk Bey mentioned that rather than like this kind of triangular based spatula, yeah, this one actually, this one should be a better.
Sizde de varmış hocam. Hı-hı. Buna
Okay,
benzer bir şey.
this one. Okay. But even thinner than this. Bundan da daha incesi galiba değil mi
Aynen
Selçuk
hocam.
Bey?
Yani yani her yerini eşit miktarda mermerin üstüne yaymaya çalışırız ki ısı homojen olsun.
Okay, so narrower spatula will work better so that the chocolate will have same temperature within the marble. Okay, any questions regarding chocolate science, chocolate chemistry? Yes.
Just want to ask that this Turkey import the raw chocolate beans.
Oh yeah, we import the cocoa beans.
Okay.
Selçuk Bey, where do
Üreticisi
we
değiliz,
import
evet.
mostly the cocoa beans? Where do we
Üreticisi
import?
değiliz hocam. Türkiye evet ihraç.
Nereden?
İthal eder evet Türkiye'de.
Nereden ediyoruz genelde?
Hocam yani çok fazla yer var. Genelde ağırlıklı bu Kolombiya tarafı. Ama ana tedarikçileri söyleyecek olursam mesela işte Berry Callebaut gibi, ADM gibi onların kakao çekirdekleri kullanılır.
Anladım. So they are using the cocoa beans of Berry Callebaut mostly. So you buy from these companies. Bu
Evet
firmalardan
hocam.
alıyorsun.
Evet
Okay.
hocam.
Bir de fil dişi sahilleri galiba. Ivory Coast bildiğim
İnan
kadarıyla.
hocam tam yanlış bir şey söylemek istemiyorum. Çok emin değilim.
Okay. Ivory Coast is the most cocoa bean producing country in the world. So. Okay. So as you realize, so chocolate is not so simple. So we have a lot of chemistry and science behind. I hope everybody enjoyed the workshop. So I think it is time. I mean, later on we will taste again the chocolate. So if you don't have any questions or any comments, we will just finish the workshop. Yes. Okay, we have a question to ask you, Selçuk.
Buyurun.
Can you replace the cocoa mass with cocoa butter and then increase with cocoa powder and then increase the cocoa butter?
Okay. Şunu soruyorlar. Kakao kitlesi yerine kakao tozu kullanıp yağ miktarını arttırsak da çikolata yapabilir miyiz?
Tabii ki yapabilirsiniz hocam. Yani bizim için önemli olan
Kodeks
kakao.
uyar mı yine? Kodekse uyar mı?
Kakao maddesini kodekste belirtilen miktarda yakalarsa, yağsız kakao kuru maddesini kodekste yakalarsa sıkıntı olmaz. Ki yakalayabilir hocam. Yani kakao likörü demek zaten kakao tozu ve kakao yağı demek.
Okay. If you catch the limits of this non-fat solids or whatever all ingredients within the codex, that is possible. Okay, we got our answer. Teşekkür ederiz.
Thank you.
Çok teşekkür ederiz. Çok güzel oldu Selçuk Bey.
Rica ederim hocam. Yordum sizi tekrardan.
Sizden sunumunuzu rica edebilir miyiz? Onu İngilizceye çevirip web sayfasına koyabiliriz çünkü.
Tabii gönderelim hocam.
Tamam. Çok teşekkürler. O zaman kolay gelsin size.
Görüşürüz hocam.
So we say bye to you.
Evet.
Mariana Hoca is saying bye. Thank you so much. Görüşmek üzere.
Görüşürüz hocam. Kapatıyorum.
Okay, so people on the Zoom, I think it's time to close the Zoom. We will have the tasting. So thank you so much.